here's the last little bit of material from this section. It's not in the book, but it is on the homework. So you are expected to know what to do. It's not a difficult thing to do. It's just a matter of are you entering the information in the right way. All right. The concept is called rewriting as the sum of terms. So if it gives you an expression or a fraction and asks you to rewrite it as the sum of terms, what it means is you're going to take each individual term from the numerator and you're going to divide it independently by that denominator. So what that means is the steps for rewriting this expression would be to separate each of the terms from the numerator. And then each one you're going to divide individually by that common or that denominator. So do you guys see how this is kind of the reverse process of combining your fraction? And so now you take your common fraction and you extend it so it's individual terms. And then what you're going to do is simplify each individual term. So using the different methods for simplifying your fraction, here the x's cancel. So you're left with 3/2 x. Oops. Cancels the second fraction. The x's cancel completely, leaving a -7/2. And in this last one, when you write these, you're going to rewrite these and you're going to use rational powers. And these powers are going to be negative if necessary. Okay, so you're not going to physically write the variable in the denominator. So when that does occur, which it will, you're going to write it using a negative power. So what negative power illustrates that x to the first is in the denominator? -1. Okay, and so this would be your answer. And the way that you enter this, or the way that it needs to be entered online, is the following. Write your rational coefficient first. So 3/2 in this case, x, -7/2 plus 5/2 x to the, and anytime you have a rational or negative power, put the power in parentheses. Okay? You still are going to write it from the highest power to the lowest power, okay? But this is what it would look like as far as the form of entering it. Mike?
Why is x raised to -1?
Because it represents that if you move this x to the top, or if you use the same division rules, when you divide two exponents with the same powers, you subtract. So 0 minus 1 is the power of -1. So
Why did you pick 3x?
when I want it to be consistent, because it won't always be, like if you try to put like 5x to the -1 over 2, it can get confusing where that 2 occurs. So I just want to go, this is the same order that you would write it in your calculator. Order of operations say you divide before you multiply, so it's 3 divided by 2. It takes that whole quantity, then multiplies by x. Okay, are there questions about that form of entering? All right, so here, this is an example of an easy type of problem that you might see. A little more challenging one would look something like this. Okay, see if you can simplify this and rewrite it as the sum of terms, please. All right, so as you go through this, you separate each individual term from your numerator, and each one is going to be divided by that denominator. Well, when I write my denominator, I'm going to go ahead and write it in rational power form. So the square root of x is what rational power? X to the 1/2. So I'm just going to write that in each of these. And now as I go through to simplify them, I have my 2x to the 5 minus 1/2. Well, 5 is how many halves? So if you think of this as 10/2 minus 1/2, you get 9/2. Plus 5x to the, here, 2 minus 1/2. Well, 2 is how many halves? So 4/2 minus 1/2 is 3/2. And then finally a minus 1, so you don't have to write anything. Move the x up. And when we move this up to the numerator, it becomes a -1/2. Okay, so here would be your answer. If you were writing it out, the way that you would enter this online would look like the following. to x to the power of 9 halves plus 5x to the power of 3 halves, and I'll continue it down here, minus x to the power of negative 1 half. So again, anywhere there is a rational or negative power, please include it in the parentheses when you illustrate that. All right, questions about this?